All right, we're back. We are in Calc AB Notes 17, the last page. I mean, the notes started out being about accumulation functions, second fundamental theorem, but really I feel like at this point we're just doing a lot of calculus. And I think that's good because you don't just constantly want to be learning. You want to be trying to use everything that you know. So let's see how it all comes together in this problem. So we are given that g of x equals the integral from 4 to x of f of t dt, and that the graph of f of x, I always say f of x, I should just say f because it's a little less confusing. It's actually a little more ambiguous if it just says the graph of f, because it could be the graph of f of t, f of u, f of r, whatever. The graph of f is shown below. So this is the graph of f. That's interesting. So let's see. We want to find the values of g of 2, g prime of 2, g double prime of 2, or explain why they don't exist. So it's possible they don't exist. All right, so g of 2 should be, according to this thing, g of 2 is going to be the integral from 4 to 2. Ew, right? Upper bound is smaller than the lower bound. That is not okay. We're going to flip that in a second. Of f of t dt, which is the negative of the integral from 2 to 4. That feels better. Of f of t dt. You always want the lower bound to be smaller than the upper bound, so that when you look at the graph, moving from left to right makes sense. You want to do everything moving from left to right, and the lower bound should be on the left, and the upper bound should be on the right. So that's why we are flipping it and changing the sign. Then conceptually, it's just like easier to deal with. So from 2 to 4, I don't know how much I'm going to have to like erase as I do these, but 2 to 4 here, maybe perhaps a different color. Let's see. 2 to 4, go back, go away, go, oh, there we go. So here to here to here. Okay, so what is that? That's half of a rectangle that is 2 by 3. That would be 6. So this overall is 3, but it's negative 3 is our final answer because of the negative sign, because we flipped the bounds. So this is going to be the negative of 3. So g of 2 is definitely negative 3. All right. So the next thing we want to do is find g prime of x so that we can find g prime of 2. So you want to do this step. So g of x is up here. It's an accumulation function. You get, like, almost always, this is a really common problem. Like when you take your AP exam, I would not be surprised at all if there's a problem that features a graph like this with an accumulation function. And that's basically these questions, because we're pretty deep in the material now. We know how to do a lot of stuff. So g prime of x is going to be the integrand, which is f of t, with the upper bound subbed in. So that'll be f of x times the derivative of the upper bound. So g prime of x is actually just f of x times 1, but I'm not going to write it. So that means that g prime of 2 is f of 2. Now this is the graph of f of x. So f of 2, we just have to look and say f of 2 is 3. So we know that this is going to be 3. Okay, so now we need to find g double prime of 2, or explain why it doesn't exist. So g double prime of x should be f prime of x. Now, if you look at the graph of f, what's happening to the graph of f at x equals 2? Well, there's a really sharp turn. The graph of f is not differentiable at x equals 2 because of that sharp turn. So I'm going to say, therefore, g double prime of 2 does not exist. And we need to give a reason for that. So why does it not exist? I'm going to say because f prime of x. Well, I guess I should say because g double prime, which is equal to f prime. I don't know if I need to say that, but I'm going to. G double prime of x equals f prime of x. Oh, no, no. Oh, I'm sorry. No, it's because g prime, not g double prime, because g prime, look at that. You got to work your way through these things, because g prime of x, which equals f of x, has a sharp turn. Now, the question is that enough? And I don't know the answer to that. So what I'm going to do is I'm going to offer you an alternative solution that's more involved. So sharp turn or corner has always been an acceptable reason. So the graph of f of x has a sharp turn at x equals 2. which means f of x is not differentiable, which means that its derivative doesn't exist there. So there's no way that f prime could exist there, so g double prime doesn't exist. Another argument could be that we could actually find g double prime. So an alternative argument here, I'm going to make it in green, I guess. So an alternative argument might be that the limit as x approaches 2 from the left of g prime. So I want to use g, like let's just say here g prime of x equals f of x. So I'm going to use f of x minus f of 2 over x minus 2. So that's the limit definition of the derivative. So and this doesn't look like a 2, so let me fix that. Get out of there. Get better. Whoa, where are you going? Here we go. 2. All right, so that's the limit definition of the derivative. From the left, what is the slope from the left? Well, look at the graph from the left, and you can see that the slope there is up 3 and over 2. So this is positive 3/2, while the limit as x approaches 2 from the right of f of x minus. So this is, I'm kind of trying to future-proof this video. The sharp turn corner thing has always been acceptable. Will it be acceptable this year? I don't know. Will it be acceptable next year? I don't know, because it's kind of a wishy-washy thing. So this is if I approach 2 from the right, well, I would have drawn that in the opposite direction. 2 from the right is like this. So that's got a slope of negative down 3 and over 2, negative 3/2. So this is a better reason. So therefore, the limit as x approaches 2 of f of x minus f of 2 over x minus 2 does not exist. So g double prime. So this would be trying to find f prime of 2, right? So f prime of 2 equals g double prime of 2 does not exist. This is a better answer, but like for obvious reasons, I don't like it as much. I mean, look at all that writing we have to do. My initial response, g double prime of 2 doesn't exist because g prime, which is f of x, has a sharp turn. That's a great reason. That's the reason. It's not very mathematical, though. The mathematical reason is this. The limit of the derivative from the left doesn't equal the limit of the derivative from the right, which means the derivative doesn't exist because derivatives are limits. So that's a better answer, but it's a lot of work, like a lot of work, and I don't blame you for not wanting to do it. Let's see if we can do the next one. Right, the equation line tangent to g of x at x equals 5. All right, I need to know g of 5. So g of 5 is the integral from 4 to 5 of f of t dt. Integral from 4 to 5 of f of t dt. Let's go to the graph and geometrically figure that out. The integral from 4 to 5 is going to be, I'm going to use this color, 4 to 5 right here. Right, so this is negative 1/2 because we're below the axis and we're moving from left to right. So that's negative 1/2. And then I'm also going to need, so this is negative 1/2. I also need g prime. So g prime of x, we know is f of x by the second fundamental theorem. Sorry, mess it up. Which means that g prime of 5 is f of 5, which is, f of 5 is down here at negative 1. So negative 1. So our tangent line, this is a good problem. This is all standard stuff that you're going to find yourself doing. So the tangent line is going to be y plus 1/2 equals negative 1 quantity x minus 5. All right. You know what I'm going to do? I'm going to stop the video here. So we can take a pause. I'm going to come back. I'm going to finish the whole page. So I will be back in the next video to do that. And I hope you are with us and I hope you're finding this helpful. So see you then.